Thanks for joining us. My name's Bryant. I'm a sales engineer with Trend Micro based in Canberra. I see a couple of familiar faces who have probably already had a chat today. So today we're going to be having a quick look at how we can automate some security aspects for your hybrid cloud environment. All right, so just quickly to touch on this, we all know that the IT landscape in general has changed a lot, especially in recent times. So we've seen a move from physical to virtual servers, a big push to public cloud, and in more recent times, push to containers and serverless architecture as well. So what we really need is a security solution that's able to adapt and evolve as well, and we will therefore be talking about Trend Micro Deep Security today. So have any of you guys used Deep Security before? You haven't used it? Okay, cool, all right. So a quick breakdown. So we've got a couple of slides to get through, and then we've got a couple of at the end. Sorry, the audio's cutting in and out. It's not my fault, I promise. All right, so Deep Security is our server security platform. It can be used, so from a single console, you've got the ability to protect not only on-premise, so connectors to Active Directory, VMware, Hyper-V, Nutanix, but from the same console, we've got the ability to protect cloud workloads as well, so connectors to AWS, Azure, vCloud Air, IBM Cloud, and Google Cloud as well. All right, so we're going to go over the modules that make up Deep Security. First and foremost, we've got a new image scanning capability. So this is with a product called Deep Security Smart Check. It's only just been introduced to Deep Security. Essentially, so it's delivering pre-runtime scanning of Docker images, and it's allowing for image-borne threats to be remediated prior to deployment. So next, we've got a couple of licensing bundles that make up the rest of Deep Security. These licensing bundles can be bought individually or as enterprise to include everything at a cheaper rate, obviously. So first, we've got network security. It consists of a couple of modules. First and foremost, we've got host-based firewall. So this is bidirectional, it's stateful. It's great because you can go in and obviously configure the firewall policy from a centralized console and have a look at logs at the centralized console as well. Next, we've got Intrusion Prevention. So this is host-based IDS, IPS. The module itself consists of around just over 6,500 IPS rules at this point in time, and these rules can be used to protect against a whole host of different types of attacks. So I think things like SQL injection, cross-site scripting, protection against heartbleed and shell shock and stuff like that. So we'll actually be talking a little bit more about intrusion prevention, and one of the demos we've got is a brand new Apache Struts attack and how we can use the Deep Security IPS module to protect against that new attack. Okay, so the next licensing bundle is called System Security, and that's got a few modules contained within it. First and foremost, we've got Application Control. So this is a new module that was introduced with Deep Security 10 last year. It really shines in terms of cloud workloads and automation. So essentially how it works, when the module's enabled on a server, it will whitelist everything that's on there. So it's great if you've got a gold image that you know is trusted and secure. And then it can monitor for drift and block any new applications or code from running on that system. So a couple of cool little bits with that. We've got what's called maintenance mode. So if you pop a server into maintenance mode, you can carry out any of your changes, install your software, run your code. When the server's taken out of maintenance mode, any of those changes made will automatically be added to the whitelist. So next we've got integrity monitoring. So this module will build a baseline of each of your systems and then alert to any deviations to that baseline. So things like if maybe you want to be notified if people make changes to a specific folder or a specific file. So the Windows host file is a good example. Yes, it could be legitimate, but there's a good chance that a malicious actor is going to get in there and change the host file, for example. Things like services going from automatic to disabled is another good example. So next we've got log inspection. So this is monitoring all operating system and application-based logs. Can think of it essentially as a mini SIEM. And the last licensing bundle is malware prevention. So this includes web reputation, which is great for VDI deployments. and anti-malware module. So anti-malware module's had a bit of a facelift. Yes, it's still great at protecting against viruses and malware and Trojans and all that sort of stuff. But it's also now got enhanced behavior monitoring. So this module is actually really good at dealing with ransomware in an automated approach. So essentially, the module will look for suspicious processes, and if they carry out a certain amount of encrypts or renames in a certain amount of time, if the module detects this, it can automatically back the files up, kill the process, and then automatically restore the files as well. So we've also introduced machine learning into Deep Security 10 and sandbox analysis integration with another product, which is Deep Discovery Analyzer. Okay, so this slide sort of shows the theory and methodology behind how deep security works, which modules work at what time. It's not exclusive to deep security, so we try and take this approach with all of our products where it makes sense. So essentially, if you can imagine a whole bunch of data and files intended for a system being protected by deep security, this data is made up with known good, depicted by the white circle, known bad, depicted by black, and unknown data, which is the grey circles there. So what we want to do at the very first layer is get rid of all of the known good files, so using mechanisms such as application control. Get rid of all of the known bad files, so using mechanisms such as signature-based protection, reputation-based protection, IPS, firewall, simple techniques that don't require much compute resources. What happens next is that the unknown files will filter through some of the more advanced and sophisticated types of engines, so things like machine learning, behavior monitoring, and sandbox analysis. So there's a couple of reasons why we do this. First and foremost, it's good for performance for machines. So by getting rid of most of the noise and the fluff at the first layer with simple techniques, we're allowing, again, the more sophisticated engines to focus on what they should be focusing on, so the unknown data. We don't want to throw everything at machine learning. Yes, machine learning is good, but it's going to bog down a system. A couple of other reasons, so false positives. We're reducing the amount of false positives by taking this approach, reducing the amount of time required to train your AV solution, or deep security in this case. It's very simple to deploy, and offers better security as well. All right, so we're going to touch on Smart Check again now. A couple of slides to go, then we'll go into the live demo. Yay. So this is an example of where Smart Check can be used and fit into your CI/CD pipeline. Okay, so step one, developers commit their code to GitHub. The Jenkins will then orchestrate the build and push the image into the registry. So this is essentially where Smart Check fits in. So Smart Check is deployed as an autonomous container, and it's used to scan for vulnerabilities and malware within the registry. So the Smart Check API includes a webhook that allows CI/CD components to register and receive notifications from services, so ServiceNow and Slack, for example. So this can be tied in, so the automation administrators can see that and see if an image needs to be pulled and fixed for whatever reason. So this is then pushed to orchestration tools like Kubernetes and Docker. So I'll just touch on this quickly. Deep security can be used for scanning Docker images, yes, but it can also be used to protect Docker hosts and Docker containers. We don't have a lot of time to get through that today, but if you've got any questions about that, please come and see me or one of the friendly Trend Micro representatives at the Trend stand on the other corner. All right, and Smart Check is able to carry out scanning based on current information because it's leveraging the Trend Micro Smart Protection Network. So the SPN is essentially our global threat intelligence service. So it's hosted by Trend Micro in our cloud. And how it works, so the SPN is receiving feeds from hundreds of millions of endpoints around the world. All of our majority of our consumer and corporate-based customers. We've got big data analytics, we've got machine learning, we've got threat researchers that are looking at this information and churning it into useful feeds for products like SmartCheck and other products as well. All right, so we touched on the IPS module just before. The IPS module, so we offer what's called virtual patches. Virtual patches are a way to protect your systems up until the point in time where you can apply a physical or an actual patch to that system. So virtual patches are very easy to deploy, so you can either jump in and ticket for individual systems or for policies of groups of systems. But we have an even easier way of deploying the patches, and we do that through what's called a recommendation scan. So the recommendation scan will run on a schedule, usually once a week, once a fortnight, once a month, usually in conjunction with whatever your main operating system patch cycle is. So if it's Windows, we're looking at Patch Tuesday or Patch Wednesday for us. So what the recommendation scan will do, it will go through and scan each of your systems. It will determine what operating systems are installed, what roles, what applications are installed. If it sees any gaps, so if, for example, Windows is 2 months behind in patching, you might have an Apache server that's 6 months behind in patching, it can automatically apply a virtual patch until you get around to applying the patch. So it's a great automated way of dealing with patches, mitigating the need to go and patch immediately as soon as new software is available. So the same thing goes for pulling a virtual patch. It's very simple to do. So you jump into the policy and you untick it. Don't need to worry about managing rolling restarts and patch pulls with WSUS or SCCM, which is not a fun task. So we've got the, sorry, I said I wouldn't turn that way. We've got the WannaCry example down the bottom left. So we know it's a bit of an old example, but as I'm sure we're all aware, WannaCry outbreak happened in May of 2017. And this is despite the fact that patches were available 2 months prior to that by Microsoft. So we had lots of organizations around Australia, government and non-government, that were pulling in resources over the weekend of the outbreak to ensure that all of their systems were emergency patched. And this, there's documented evidence of this causing issues. So we had a couple of hospitals up in Queensland that had production systems go down because they had to emergency patch so many systems. Any of our deep security IPS customers weren't likely bringing resources in over the weekend. All right, so let's jump into the demo. So the first demo that we're going to do today is a quick overview of SmartCheck. Of course, I've been logged out. Cool. All right, so when you log into SmartCheck, greeted with the dashboard, we've got a couple of bits of useful information here. So scan coverage metrics, how many images have been configured to be scanned and how many have been scanned. We've got vulnerability count, so how many vulnerabilities have been found within scanned images. And we've got a malware count, so how many pieces of malware have been found within the images as well. So apologies, we had a bit of a misconfiguration issue in the back end. That's not showing how it should be. We've definitely got malware found. Yeah, apologies for that. So on the right, we've got some statistics. How many registries have been configured to be scanned by SmartCheck? How many repositories and how many images are contained within those registries? How many scans have been completed in the last 24 hours and the last 7 days? All right, so down the bottom we've got views. Views are a way to look at scan information. So if you want to look across multiple registries for images that have WP and latest in the title, so let's just have a quick look at that. You can configure a filter to do that. So if we go back to the views, we can see that here we have 2 images across 2 different registries that have WP, WordPress, and latest in the title. So we're looking at scan information against those images only. Okay, so to continue the demo, we're going to jump across to Jenkins. So here in Jenkins, we've got a number of builds. I'm going to be showing you a couple of those builds now. So the first one is Bryce Web. This stands up just a basic web page. So we're going to kick off the build. Accept the Git repo. Okay, So here we can see the various stages of the build. We've got a couple of prerequisite steps, so checking out the SCM, preparing the build and sending it to the repository. So obviously, because we're demoing Smart Check today, we've got a step in there to scan for malware and vulnerabilities by Smart Check. So once that kicks off in a couple of seconds, we can jump across to Smart Check, go to Scans, and it hasn't kicked off yet. And that will appear under here to say that the image is currently being scanned. So we can see here that, start singing. We can see for Bryce Webb that we've had a number of successful builds, and the average time for a scan to take place on this build is between 3 and 5 minutes. So obviously, if Smart Check doesn't pick up any malware, it will pass the build and it will get deployed to production. So if we go back and have a look at another build now, we'll look at the Bryce portal. So we can see on the left here, we've got a nice big red exclamation mark to say that the build has failed. If we go into that, we can see that the preliminary steps have all passed. However, the build has failed on the Smart Check stage. So if we want to see why the build has failed, we can click on Logs, scroll down to the bottom highlighted line, click on that. It's just being a bit slow. So we can see here that Smart Check has picked up some malware. Now it's all frozen. I broke it. Blame Alex. It's the marketing guy's fault. Okay, so we got mouse back, which is good. So obviously that doesn't show us a lot of information. It shows us that the build has in fact failed. If we want to have a look at some more information about why that failed, we can jump back into the Smart Check scan history. So here we can see all of the builds that have been completed. This little icon here means that a scan has failed, so that was me just messing around with the environment yesterday. A build that has the lightning bolt, so that means that a scan has completed, however, a number of vulnerabilities have been introduced by that build. And this scary looking icon here, so that means that malware has been introduced by the build. So if we have a look at this, this is one of the Bryce portal builds. So we can see some statistics here, so when the scan was completed, how long the scan took to complete, and the fact that 3 pieces of malware have been found by Smart Check. So if we scroll down to the bottom, we can see the various layers that make up the build. Right down the bottom, again, we've got the malware icon. We can see that this particular command was run that introduced malware into this build. So a copy from this directory into the var www.html folder, and these were the 3 pieces of malware that were introduced. So we've got a couple of ICAR test files and Trojan as well. So we've also got a vulnerabilities table here. This shows us how many vulnerabilities have been introduced into the build. So again, going down and looking at the layers, the tick icon here means that this particular command that was run was good. No malware was found and no vulnerabilities were introduced. However, if we have a look at this layer with the lightning bolt, we can see that an update was run and an installation of PHP-Eyes. And with the installation of that software, it's introduced all of these vulnerabilities. So if we have a look at one of the vulnerabilities, so we can see a description of the vulnerability, what version the vulnerability was introduced by, and any subsequent versions of that software where the vulnerability's been fixed. So a DevOps member can jump in, have a look at this information, and potentially fix the code install a later version of this software, one that hasn't got that vulnerability present anymore. All right, so we'll just finish off the quick tour of SmartCheck. Registries, so that's going to show you how many registries are being configured in SmartCheck. Users is fairly self-explanatory, so you can come in and add additional users as required. And we've got an API documentation page. So quite thorough in terms of API documentation. I won't go through all of this now, we definitely haven't got enough time. However, if you are not currently a SmartCheck customer, which is most likely the case because it's only brand new, come and have a chat to us after this at the stand. More than happy to share this information with you and give you a bit more of an overview. All right, going pretty good for time. All right, so that's the SmartCheck demonstration. Now I'm going to show you a quick demonstration of a brand new Apache Struts attack. So the attack was disclosed on the 22nd of August, and we had a deep security IPS rule available to cover that the day after, on the 23rd of August. So we've got a vulnerable web page here. We have the Apache Struts attack code. So this is based in Python. I didn't create it, I didn't write it, so if you've got any questions, sorry, I can't help you there. Basically what we're going to do is we're going to run this Python code. Can everyone see that? Python struts on the vulnerable web page with a showcase action, and then the particular command that we want to run. So we'll start off with a print working directory. So we can see that we're in the Tomcat folder. If we want to do, who am I? Yeah, sure. What do you think it's going to say? Root. Cool. So as simple as that, we've got root access to this system. I'm not a hacker, I'm not a pen tester. It took me all of about 2 seconds to figure out how to do this. It's pretty cool. So we can come in and do an ls of the root directory. We can come in and very simply drop a new file there. It would help if I probably did it right. There we go. So we've just dropped a brand new file in the root directory called aws2018.txt. Simple as that. All right, so what we're going to do now, we're going to run the same attack against a system that is being protected by deep security. So it's the same version of Apache Struts. However, we've got a deep security virtual patch applied to that system to hopefully stop this attack from happening. It'd be pretty embarrassing if it didn't work, but I've tested it, so we should be right. Okay, so we can see that existing connection was forcibly closed by the remote host. So now if we jump into the Deep Security Manager console, sign in just quickly. All right, so this is a quick look at the Deep Security Manager console for those that haven't seen it before. Don't really have time to go into all of the components now, but if you'd like to organize a demonstration of the product, so a thorough demo, or set up a trial or a POC, again, please come and see us after this. I'll be more than happy to, to accommodate that. So I'm going to try not to move too much. All right, so let's have a look at the attempted Apache Struts attack. So looking at the dashboard at the IPS event history, if we click on today, so here we can see we've had a hit on Apache Struts OGNL. It's nearly finished. Hey, you came. All right, so we can see the reason we've got an Apache Struts OGNL remote command execution execution vulnerability, and we've got the CVE number here. So if we click on the CVE number, it's going to give us some more information. We've got some information about the vulnerability. So, sorry, we'll go back here. We can see when it was released. So we had the deep security rule available on the 23rd of August. It's been updated since then, but that's when it was available. Information about the vulnerability, so what versions of Apache struts are susceptible to this type of attack. And this here shows that this particular rule can be applied via the recommendation scan that we talked about before. So if you've got an Apache system that is susceptible to this attack, the recommendation scan can automatically protect you against the attack that I just showed you guys today. All right. So a couple more slides to go, and then we will have a couple of minutes for questions. So I just wanted to quickly touch on the new automation center. So this was updated for Deep Security 11, which has only recently been released. So basically, if you log on to this website, again, come and see me after if you'd like details of that, or you can just Google it. Lots of information about how deep security can be driven via APIs. I think I've already got it open here, so I can show you what that looks like. Lots and lots of good information here if you guys like to work with APIs. So that's using the RESTful API. All right, so in finishing, deep security is the current market leader. So it's got around a 30% market share. And it's been a leader in server security for over 7 years now. So very popular, fantastic tool for protecting your server workloads no matter where they are.